Today, lesson 24b, day number 2 of solving proportions. So we're going to extend out what we talked about yesterday. All right, let's go ahead and get started. A little bit of background knowledge here is what we did yesterday. We tried to solve proportions either by scaling up or scaling down, or trying to figure out what we were multiplying or dividing a given ratio by to make the other ratio. Remember, proportions are situations where we have two ratios that are equivalent to each other. And I know some of you are looking in your notes right now. This is not number one. This is background knowledge. Normally we don't have background knowledge in the notes. So here was one that we did yesterday. We practiced by scaling up until we finally got a numerator of 20, or we looked at to see what we could multiply the denominator by to make 25. And we did the same thing with the numerator, and most of us chose to do it that way. And in this one from yesterday, we ended up with n equals 25. Here was another one that we did. We did it by scaling down, which is taking the given ratio, reducing it all the way, and then scaling back up until we finally get a denominator of 60. And there we have it. So that means that the variable is 16, or n is equal to 16. And another way of getting there would be dividing both numerator and denominator by 2. And most of you went that route. So that was very easy. But what if you can't multiply or divide by a whole number to make an equivalent ratio? So here is now number 1. Can you think of what you could multiply 4 by to make 21? Well, believe it or not, there is something that you can multiply it by. And that would be multiplying it by 21/4. And I would like you to go ahead and write that next to the 4. So if we're going to multiply 4 by 21/4, we would have to do the same thing with the denominator. Now, if you don't believe me that 4 times 21/4 is 21, I will show you. 4 over 1, I'm doing it down here now. So if I take this and turn it into 4 over 1 times 21 over 4. We can do some cross-dividing right there. And you can see that we end up with the 21. So if I'm going to do that, I would need to do the same thing right there. And so if I do that, 5 over 1 times 21 over 4. So what I'm doing is I'm doing this multiplication right here. I can't do any cross-dividing, so I multiply straight across, turn it into a mixed number, and I end up with 26 and 1/4 for n. So n is 26 and 1/4. And I already know many of you right now are like, what in the world are you doing? Well, listen, we're going to take a different approach on most of these, but I want to go ahead and show you how you could do any proportion this way. And then you'll just need to make up your mind. If you understand it this way, this might be a better method for you. If you don't, I have another method for you. Okay? So let's take a look at number 2. Anybody have any idea what I can multiply 2 by to make 13? And as we go through here, a couple more of you each time will kind of see what's going on. Anybody see? Take a shot. Yes.
13 over 2.
13 over 2, exactly. 2 times 13 over 2 is 13. Now, if you don't believe me, I'll do the work down below. But remember, if I'm going to multiply the 2 by that, I also need to multiply the 9 by that. But I'm proving it to you right now. I took this, did the multiplication right there, did a little bit of cross-dividing, and I ended up with 13. So that proves that it is 13. But now I would need to do the same thing with the top number. So 9 times 13 over 2, we would need to figure that out, so I'll do it right here. 9 over 1 times 13 over 2 is 58 and 1/2. So that means that n is 58 and 1/2. The solution is 58 and 1/2. Let's take a look at number 3. Anybody have any idea in number 3 what I could multiply 3 by to make 11? Bring that problem up. Yes?
11 over 3.
So already, we have a few more this time who have kind of seen what to do. So if I multiply 3 by 11 over 3, I will get 11. And I'll prove it to you right now. 3 over 1 times 11 over 3 is 11. So here's what I want all of you to do right now. I want you to now try and multiply 7 by 11 over 3 and tell me what you get. Okay, so 7 times 11 over 3 is 25 and 2/3, so the solution is 25 and 2/3. All right, I'd like everybody to try number 4. Now don't worry if you're struggling with this method. I'm going to show you a different method that is probably a little easier, but it probably takes a little longer. And you'll have to make up your mind which method you like the best. Chris, tell me what we would have to multiply 3 by to make 22. 22 over 3. And hopefully you've seen that pattern by now. So proving it to you, 3 over 1 times 22 over 3 is 66 over 3, which is 22. So that means it will work. So Daniela, did you get the solution?
The solution is
36 and 2/3. Let's see if that's right. We need to multiply 5 by 22 over 3. That's 110 over 3, which is 36 and 2/3 for the solution. All right. So some of you will be okay with that method. But others, I know from experience, you're probably a little confused on how exactly we're coming up with these numbers right here. So I'm going to show you now a different method. And so right now, we're going to take a look at number 5. Now before we deal with number 5, listen. We have solved probably 1,000 problems similar to this year. So if I had a problem or an equation like this, x over 3 equals 4, how would I solve that equation? Yes?
Put a 1 underneath the 4.
Do I need to? Do I really need to do that? I could. Yes?
Multiply 3 both sides.
Yeah, some of you have forgotten that this is just a one-step equation and we multiply both sides by 3. Right? Because what we're trying to do is we're trying to make 1 right there. That's the multiplicative inverse property. And so I end up with x equals 12. Now I want you to keep this in mind because what we're going to do is we're going to utilize that method to solve a problem like number 5. So number 5 is x divided by 3 equals 4/5. So let's multiply both sides by 3. Now when we do that, on the left-hand side, we've created 1 just like we wanted. So we have x equals, but the difference now is we need to figure out what 4/5 times 3 is. So if it makes you feel better, put a 1 underneath. And if we can do some cross-dividing, we should, but it doesn't look like we can. So we end up with x equals 12/5, but we need to figure out what that is. 12/5 is 2 and 2/5. So the point is this. We have solved hundreds, if not thousands, of equations like this year. It's utilizing that same exact strategy of just multiplying or dividing by something, not too dissimilar from what we talked about yesterday. So one more time. I multiplied both sides by 3. That's the multiplicative inverse property because we're trying to make 1 right there. And now we need to put a 1 underneath the 3 if that makes you feel better. And we need to figure out what 4/5 times 3 over 1 is. That's 12/5, but that is 2 and 2/5. Now, what that means, this is what we started with. We started with x over 3 equals 4 over 5. We were trying to make this thing into a proportion. We figured out that x is 2 and 2/5. So that means that 2 and 2/5 over 3 is equivalent to 4/5. We just created a proportion. This is equivalent to this. So in sentence form, 2 and 2/5 over 3 is equivalent to 4 over 5. All right, I would like everybody to take a look at number 6. What is different about number 6 compared to number 5 is the fact that the variable is in the denominator. So how are we going to deal with that? Well, when the variable is on the bottom, like this, and this is not the same problem as your number 6, it's actually the same problem as your number 1. but we can use something called the upside down property of proportions, and I believe this is where you need to fill something in. A true proportion is also true if you flip it upside down. And the reason we want to do it this way is if you're going to use this newest method that I just taught you, the variable needs to be on top. So as far as this proportion goes, we can just use the upside down property, flip it over, and make it look like this. Do all of you see what I did? Yes or no?
Yes.
All right. So with the variables on the bottom, and you want to utilize this method of, like this, multiplying both sides by 21 to solve, then you would need to use the upside down property. Okay? All right, let's go to number 6. First of all, use the upside down property. So what does it look like after you use the upside down property? What does it look like? Go. Equals what? 3/8. You can't just flip one thing. You have to flip the whole thing. If you look back at the previous problem, that's what I did. Doesn't it have to be 8/3? Right? You have to flip the whole thing. All right, now, I don't care which method you use to solve it, solve it. Okay, so the first time through, I'm going to do this the first way that we learned. If we're going to do it that way, then that means we would have to multiply 3 by 7/3 to make 7. 3 times 7/3 is 7. So that would mean I would need to multiply 8 by 7/3. And so right there, 8 over 1 times 7 over 3, that's 56 over 3. And that's like 18 2/3. Okay? Or the newest method, which really isn't a new method, it's just the same way we've been solving equations all year long. W over 7 means W divided by 7. The inverse property to dividing is multiplying. Or you're trying to create one right there with the multiplicative inverse property. So if you're going to multiply that side by 7, you have to multiply the other side by 7. We made our 1 right there. And so now we need to figure out what 8/3 times 7 over 1 is. And just like in the previous method, it is 18 2/3. So the solution is 18 2/3. Pick your method. All right, let's go to number 7. Everybody try number 7. And like in the previous problem, 18 2/3 over 7 is equivalent to 8 over 3. Let's take a look at number 7. Question. Do I need to use the upside down property in this one? Yes or no? How do you know? Because the variable's on bottom. We need the variable to be on top if you're going to use the new method. What does this thing look like after we use the upside down property? What does it look like?
11/3 equals y over 4.
Good. 11/3 equals y over 4. Finish it, please. So if we do this the first way, to turn 3 into 4, we have to multiply by 4/3. 3 times 4/3 is 4. So that would mean I would need to multiply 11 by 4/3. And 11 over 1 times 4 over 3 is 44 over 3, which is what Ivan said. That is 14 2/3. If you did it the new way, you would want to multiply both sides by 4, because that's the inverse property to multiply, or dividing by 4, excuse me. And we made our 1 right there, so now we need to figure out what 4 times 11/3 is, or 4 over 1 times 11 over 3. That once again is 44/3, and that is a solution of 14 2/3. So once again, rewriting this, 11 over 3 is equivalent to 14 2/3 over 4. Backside of your notes, please. Go ahead and do both number 8 and number 9. And we will shoulder partner both of those, 8 and 9. Number 8. Obviously, if you're going to use the new method, you don't need to utilize the upside down property. If you did this the first way, you would have to multiply 5 by 6/5 to make 6. So you would need to multiply 4 by 6/5 to figure out what C is. If you did it the newer way, you need to multiply both sides by 6. So we're trying to figure out what 6 over 1 times 4/5 is. That's 24 over 5. So regardless of which way you did it, the solution should be 4 4/5. And so what that means in the context of this problem is 4/5 is equivalent to 4 4/5 over 6. In case you haven't been following, all I'm doing is I'm substituting this right there, saying that that is equivalent to that. Number 9. We start with this. We don't need to use the upside down property. If you did this the first way, you would have to multiply 7 by 15/7 to make 15, so you'd have to multiply 4 by that. But if you did it the newer way, you multiply both sides by 15, and we end up with 60 over 7, which is 8 4/7 for the solution. So 8 4/7 over 15 is equivalent to 4/7. All right, let's finish off. Number 10, 11, and 12. We'll quickly compare those with our shoulder partner, and then we are finished. So once again, please do number 10, 11, and 12. Number 10, this one you will need to use the upside down property to get the variable on top. Doing it the newer way, multiply both sides by 5. Then we have 30 over 9, which is 3 1/3 for the solution. Number 11. Use the upside down property again if you're going to do it the newer way. Multiply both sides by 9. 9 over 1 times 6 over 7 is 54 over 7, but that is 7 5/7 for the solution. And then the last one, multiply both sides by 9. We end up with 72 over 12, which obviously is 6 for the solution. All right, we are finished for today.